Today I'm going to go over a couple of application problems with you involving systems of equations. Last year in Algebra 2 we didn't really do any mixture problems like this first example, so I wanted to give you an example on how to do one of these types of problems. A 5-pound nut mixture is worth $2.80 per pound. This mixture contains peanuts that are worth $1.70 per pound and cashews that are worth $4.55 per pound. But once we mix them together, the new mixture is only worth $2.80 per pound. And we want to know how many pounds of each type of nut are in the mixture. So we need to set up a system of equations to solve this. So we are dealing with peanuts and cashews. So our first equation would be something like this. We have peanuts, or we have so many pounds of peanuts plus so many pounds of cashews, and that equals a total of 5 pounds. So that just deals with the number of pounds of peanuts plus the number of pounds of cashews equals 5 pounds. Now let's deal with the mixture amounts. Each peanut, or each pound of peanuts, the original amount, is worth $1.70 per pound. So the original price, original mixture, was $1.70 times every pound of peanuts, plus cashews were worth $4.55 a pound. C for cashews. Okay, so this part right here is the only thing that's really new or a little bit confusing for mixture problems. This right here involves our new mixture and our quantity. So what we need to do here is our new mixture is $2.80 times the quantity that we're going to have, which is 5 pounds. So I'm going to write up here, this is our new mix, and then this is our quantity. So that's what you need to always do on your mixture problems. Put your new mix and your quantity. So go ahead and multiply that together. 280 times 5, that turns out to be 14. So you would just replace this number right here with 14. Alrighty, now to go ahead and solve this system, you can do elimination method or substitution. My choice would be substitution. You can do it however you want to, but my choice will be substitution. So what I'm going to do is on this bottom equation here, I'm going to solve this for P. I'm going to get the P by itself. So P equals negative C plus 5. And then what I'm going to do is I'm going to substitute all of this back in over here where the P is, and I'm going to substitute. So that's what I'm going to do down here. 170. And remember, always put parentheses where you're substituting in. Negative C plus 5 plus 455C equals, remember this isn't 280 times 5 anymore, this is 14. So I'm going to distribute. That's negative 170C plus 850 plus 455. I said 455 and I wrote a 5. 455C equals 14. All right, combine your C's. That's 285C. Subtract 850 from 14. That's 550. Divide, and you get C. It doesn't divide evenly, so it's approximately 1.93. Now think about what C means. C represents cashews, so C is approximately 1.93, and that would be pounds. Now I want to figure out if I have 1.93 pounds of cashews, how many peanuts do we have? So 1.93 goes right back in here for C, so P equals negative 1.93, because I'm plugging that in for C, plus 5, so P is going to be approximately 3.07 pounds, which is peanuts. So let's answer the question. We are going to have about 3.07 pounds of peanuts, and I'm going to do little squigglies for approximate, and approximately 1.93 pounds of cashews. So there's how you do a mixture problem. Working it out wasn't the new part. That's all review. The new part is this right here. This right here where you set up the new mix and the quantity. Okay, on this problem, we did these last year in Algebra 2, but I remember that y'all had trouble with these, so that's why I put one of these in here to practice with you. An airplane flying with the wind from Los Angeles to New York City takes 3.75 hours. Flying against the wind, the airplane takes 4.4 hours for the return trip. If the air distance between Los Angeles and New York is 2,500 miles and the airplane speed and wind speed is constant, find the airplane and the wind speed. So the first part here talks about the airplane flying with the wind. Okay, with the wind, it has a tailwind. The wind has helped pushing it along. So we have 3.75 hours of the plane flying at however fast it's going. And with the wind helping push it along, we're going to put a plus sign because the plane and the wind are helping each other out. We also have 3.75 hours of however fast the wind is going because the wind is moving along with the plane. Plus sign because they're going together in the same direction, helping each other out. And that is going to equal the total mileage that they're going, which is 2,500 miles. Okay, so that's going with the wind. I'm going to put with right there. So our next equation is going to be for going against the wind. Okay, this next one is going to be going against the wind. That's supposed to say against. Looks all squished together. Last year when we did these, we did some with the wind, then we did some like with the current and swimming upstream and downstream. Okay, so this one's going against the wind. We're still going to have, it's still 2,500 miles. The distance of the trip didn't change. But the time got longer. This time it's going to take 4.4 hours of the plane flying and 4.4 hours of the wind going. But they're fighting against each other this time, so we're going to put a minus sign instead of a plus sign. And that's our two equations. So that's how we're going to solve this. And from here, decide if you want to do elimination or substitution. I'm not going to do substitution here because it would not be very easy for me to get a W or a P by itself. So what I would choose to do is I would choose elimination. I'm going to multiply by something to get the P's or the W's by itself or by themselves. Or not by themselves, sorry, to cancel out. So I'm going to rewrite this because I didn't leave myself very much room. I'm going to rewrite this here. 3.75p plus 3.75w equals 2,500. And then 4.4p minus 4.4w equals 2,500. And I'm actually going to have to multiply both equations by something so that I can cancel out either the P's or the W's. And I am going to choose to cancel out the W's. And to make that happen, I'm going to multiply the top equation by 4.4 and the bottom equation by 3.75. And by doing that, I will cancel out the W's. So let's go through here and multiply all of these. And when I multiply all the top by 4.4, I get 16.5p plus 16.5w equals 11,000. Multiply this bottom one by 3.75. I get 16.5p minus 16.5w equals 93.75. All right, now I can add them together. The w's will cancel out. I get 33p equals 20,375. Divide by 33 to find P, and you're going to get approximately 617.42, and this is speed, so that's going to be miles per hour. That's the plane. And I need to know the wind speed, so I've got to take this, I've got to take the plane speed, and I've got to go plug it back in up here somewhere for P in one of the equations. So just pick one and go plug it in. 4.4 times 617.42 minus 4.4W equals 2,500. Multiply that. It's 2716.648 minus 4.4W equals 2,500. Subtract this, because you're trying to find W, so subtract this from 2,500. That's negative 216.648. Divide, find the wind speed, and the wind speed is approximately 49.24 miles per hour. And that is the wind. So I'm going to come up here and just kind of summarize my answer. All right, so the plane is flying at about 617.42 miles per hour, and the wind is blowing at about 49.24 miles per hour. And that is it on that.